Okay. We're going to discuss something called oblique asymptotes. Now this is something that my students last year, or all the students last year, and historically have had some difficulty with, and my belief it's because the textbook explains it really poorly. Because they're trying to use a technique that comes at the end of the year without actually using it. So in any case, when a rational function, right, so those are functions that really appear as fractions, so something like this, with gx, fx polynomials. Provided the degree of f minus the degree of g is 1, we may produce a slant asymptote. Which is useful for sketching. Which is useful for sketching. All right, so I'm going to show you how that works. So I don't really like these things too much because they're only applicable in a very specific use case. Right? You have functions, which are fractions, and the fraction is the case that the thing on the top has degree 1 more, exactly 1 more, than the function on the bottom. So I'm going to give you a strategy. So here's your strategy for finding slant asymptotes. And it will make more sense as I work through it, but I just want to outline it first. Strategy for finding slant asymptotes. All right, so a slant asymptote is sort of what you would expect. We have asymptotes that are up and down. Those are the vertical asymptotes. They happen when you divide by 0. We have the horizontal asymptotes. That's behavior at the relative negative and positive infinity. But sometimes, so you can have a function approaching a line. That's still technically going to infinity, but it's going to infinity in a particular way. It's going with a line. Right? So basically how we do this is we say, okay, provided it really is the case that this is true, we know, so first we let the limit of x goes to infinity of the function. We just say, look, this is equal to a line at infinity, this line. That's our claim. If an asymptote of this function exists, right, we should find the line, right, at infinity. We also have to do the same thing at negative infinity. Once we do this, we can solve for m. And then once you get m, you back substitute, back sub m, solve for b, the intercept. Okay, so this may make no sense at the moment, but it will after an example. So here's our example. Okay, so here's a function, and it is x squared minus 3 over 2x minus 4. And if you plot it, so first of all, we're going to get an asymptote at x equals 2. And then if we plot it, we end up getting something like this. The function will look like this if you plot it in Desmos. And what I'm trying to indicate to you is that this dotted line, the slant one, this is the slant asymptote. Let's call it L. Okay? So let's find L in this case. Really, I need to know what this line is. Oh, that's bad. It shouldn't have gone through the origin. Well, I didn't really label it, so That's not going to be the origin in the end. So let's just follow my strategy here. Okay, so I want to say, well, I claim that at infinity, that x squared minus 3 over 2x minus 4 looks like the line, this line. Okay, but who remembers what we usually do with constants when working with infinity? Like, what does this minus 3 matter when we put infinities in? No, let's forget it. What about that 4? Who cares? What about this b? No, who cares? Okay, so from this we deduce limit x goes to infinity of x squared over 2x is equal to the limit of x goes to infinity of mx. Now remember, m is independent of x, so I can actually take it out of the limit. So if I rearrange everything here, you get m is equal to limit of x goes to infinity of x squared over 2x squared, which is a half. Okay, so look, we got our slope. The slope of that asymptote is a half. So now we need the b, which is the y-intercept. So we just have to back substitute. So I'm going to back substitute into here. So for b, we're going to do limit x goes to infinity of x squared minus 3 over 2x minus 4. Is this going to be equal to the limit of x goes to infinity of a half x plus b. And now we're going to solve for b.
Did you get half?
How did I? X squared divided by x squared is they disappear.
It's 2x though. It's not x squared.
What?
It's just 2x. It's not 2x squared. The degree is just. Sorry.
I have to divide by x to isolate m. Where did this x go?
I still don't quite understand. How are you?
I
Oh, it's just.
m comes out, right?
Oh, I see. Oh, okay.
And then I have limit of this is equal to the limit of that, and the algebra limit rules say I'm allowed to combine things with limits.
Okay.
So, okay, that's fine. It's x squared over 2x, like multiplied by 1 over x then. Right?
Okay.
Yeah. No, ask these questions, right? Maybe I should have done a bit more. But sometimes I'm trying to say it out loud, so I don't have to write it on the board. Okay, so is this fine? Okay, so let's now get b. So I'm just going to do, like, it's exactly the same thing. I'm allowed to combine this with this, right, because the limit's there. So if I get b, maybe I'll do a little bit more. So this is the limit of x goes to infinity of x squared minus 3, 2x minus 4, minus the limit x goes to infinity of a half x. Okay, now we need to combine the fraction. So this is x2 minus 3. Okay, so this is 2 times x minus 2. So that means I need to multiply this guy by x minus 2, right, to combine the fraction. So it's going to be minus x minus 2. And then if you work all of that out, you're going to get what? X squared minus x squared. And then you get a minus 3, and then a minus, you get a 2x on the top and a 2x on the bottom. So this is all going to work out to 1. You can fill in the details. Okay, but I got b, I got m. That means this line here is 1/2 x plus 1. Right, so that's how you get the slant asymptote. The Thomas's explanation of this to me is totally incomprehensible. Right, but if you just follow those 3 steps, it will work every time, provided the asymptote exists in the first place. Right, but okay, so this is one extra strategy that we have for plotting things. All right, so I'm going to give you now a question, and we're going to try to do as much as we can in the next 20 minutes. And it's a very open-ended question. So maybe I'll give you, here's some, I'll give you some exercises for horizontal asymptotes, or oblique asymptotes. find the horizontal asymptotes, vertical asymptotes, and oblique asymptotes for the following. Y is equal to x squared over x minus 1. Y is equal to x squared plus 1 over x minus 1. And y is equal to x cubed plus 1 over x squared. Okay, so the last topic for today is curve sketching. And basically, use as much algebra to reconstruct a sketch of a graph. All right, so basically use as much algebra to make an educated guess about the geometry. What are all of the things I've told you that you can algebraically find about graphs? Just rattle some stuff off. Like, what are the things that we can find to help us draw a picture?
Asymptotes.
Yeah, horizontal asymptotes, vertical asymptotes, oblique asymptotes. What else?
Increasing, decreasing.
Yeah, increasing, decreasing intervals. What else?
Concavities.
Huh?
Concavity.
Yep, concavity. Right, so where are we concave up and where are we concave down?
Maximums.
Yep, maximums and mins. That is to say critical points. What else?
Intercepts.
Yep, the x and y intercepts. What are the x-intercepts also called?
Roots.
Are you reading from the notes? That's cheating. Is it the same order? At least you're switching it up a bit, right? What else do we got? So I got intervals of increasing, decreasing, local maxima and minima, concavity, asymptotes, roots, critical points, inflection points, and intercepts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think that's it. Okay, so here's your questions. Very open-ended. Plot, our exercise. Plot f of x is equal to x squared plus 4 over 2 of x. Give it a try. I'm going to wipe down the boards, and then maybe we can do as much as we can in the remaining time.
Professor?
Yes, sir.
Before you erase that, in the last step right there, when you combine the two limits,
Yeah.
why is it x and then times x minus?
Because I have to combine. This is a fraction.
Okay.
So I have to
Oh,
combine
oh.
it, right?
Okay.
There's a 2 there, so this is x minus 2 times x minus 2.
Why is it not? What am I doing?
So this is why I want you guys paying attention instead of writing. I'm saying a lot of things out loud.
So we, to have a no.
Yeah.
Okay.
2x minus 4. Yeah, because like the ratio becomes a line, and the only way for that ratio to be a line is for the two things to only differ by 1. They try to explain with synthetic division. You need to know what a Taylor series is in order for this to make sense. Well, you will, again, you will have to know what a Taylor series is by the end of this course. It's basically just how we turn anything into a polynomial. Because polynomials are This function has no roots. It's a song, isn't it? No roots? Yeah. Maybe it's no roof. Okay, asymptotes. Anyone? Horizontal asymptotes. Should be easy to read off. Limit as x goes to infinity. Well, goes to, okay, so limit x goes to infinity of f is infinity. That doesn't really help. We just know that it's going to that direction. Limit of x goes to negative infinity of f is negative infinity. Okay, so that doesn't give us any extra information. What about vertical asymptotes? Are there any? Up and down asymptotes? At x equals 0? Yeah. So we need to know what the limit of x goes to 0 from the right of f and the limit of x goes to 0 from the left. What are they? 0 from the right, what happens? Positive infinity or negative infinity? Because the thing on the top is always positive, right? X squared plus 4, always positive. So the signage is totally controlled by the thing on the bottom. Right? So if we're going 0 from the right, those are always positive. So from the right, yeah, that has to be positive infinity. And from the left, we're going to have negative infinity. Right? So we should be keeping track of what we've been discovering here, right? Like, so this is an asymptote at 0, and we have no asymptote here. So we'll just keep drawing. I don't know why I did that. Okay. What else do we know? So what about, okay, so I'm just going to tell you that the slant asymptote, I worked it out in the thing, but the slant asymptote ends up being y equals half x. Right, so that means you're going to have an asymptote that looks like this. Right, so 1, 2, 1, 2, 1, 2. So this should be 2, 2, 1. Okay, that's the slant asymptote. What else can you tell me? What about the intercepts? What's the y-intercept? When does this function hit the y-axis? When does any function hit the y-axis? For what value of x? 0. Is there 0 in the domain? No, there is none. What about x-intercepts? What about roots? Does this function have roots? You can work it out. Can it ever be 0? No, right? Top is always non-zero, bottom is only 0 at 0, and that's out of the domain. So there are no roots, which is information, right? This says that graph shouldn't pass through x-axis, right? Okay, get me the critical points, and then we'll continue. All right, so basically I need to know the intervals of increasing, decreasing. So whoever gets them first, just let me know and we can continue. 10 points on the exam. Or whatever, to Gryffindor. And don't laugh. We all know you're Hufflepuffs. You take that back.
That's a singer.
This is the y-intercept of the slant asymptote. Talking about the y-intercept of the function.
Yeah, okay. So the y-intercept of slant when I was taking it, I didn't
Should be equal to something. What I said set it equal. So that was the first thing. Infinity of 1/2.
This is what slant yeah.
Yeah, you don't have to take limits as a constant. Like you don't write x goes to infinity and not equal to
Yeah, okay. In my head, I was just writing as I was going, so I was thinking.
You think before you write that. Right?
Yeah.
You don't write that.
Okay.
Otherwise, you're wasting a lot of time.
So then it would be
X forward.
I have my I took the original.
See this? You're writing it as this. Right? This, you have a equivalence first. And then you're like deducing from that equivalence. You're trying to write it as like a big list of, it's not going to work. Right? Because I set up something like A is equal to B. And then that has to be rearranged into something entirely different. So you're trying to go A to end up B. It's not going to work.
I tried it like this. But like this. It's just
The B hasn't been isolated. What is equal to 1? Where did you see this? I can't read the board.
okay.
Oh, God, you just moved B to
Yeah,
the
just
side.
move these to the side.
So what, this is equal to this is equal to that? If you have A equals B equals C, and you're trying to move to which side? This is your first statement here.
Yes.
Okay, so that should be on one line. You need A is equal to B. And then we're going to arrange this. So then you're going to do that. This means that B is here. And then you don't need that equivalent implies that you can rearrange everything for B. And then you can do your E. Okay, that I understand. Because at least here you have to be isolated.
Okay.
Well,
Okay, I'm
then,
gonna rewrite this. Okay.
okay, who has critical points for me? Anyone? No one even wants to guess? Well, in the interest of time, I'm just going to tell you what they are, and then you can look it up in the notes for the full solution. But the critical points are 2, 2, and -2, -2. And then you should find that the increasing, decreasing information, 2 -2 is like, oh, there's also a critical point at 0. So there should also be a 0. I guess 0 undefined is in here. And you'll find that this goes positive, negative, positive, or sorry, negative, and then positive. All right, so you're increasing, then you're decreasing, then you're decreasing, and then you're increasing. Okay, so then you can do a little bit more with the concavity, but I'm just going to write in this critical points 2, 2, and 2 -2. So I know that I have to be decreasing until this point. So I have to decrease until this point, and then increase. And then that's just going to go up like that. And then I know for here I have to increase until this point, and then decrease. Right? Increasing, decreasing. Okay, so this is what the graph should look like-ish. I didn't do the concavity. Okay, so do the worksheet, and then do some of the, I'm not going to give you curve sketching problems because I gave you a ton of Desmos problems to do this week. Please keep up with them. I'm going to be adding 50 questions a week, right? I don't want you to wake up one day and have 800 Desmos questions to do. All right. Okay, so you're dismissed if you choose. Have a nice weekend.